All right, guys. So this recording that I'm going to make is the same problem that I actually recorded yesterday. However, this time I'm going to show you how to do it completely on the calculator. Yesterday it was all algebraic methods. This is going to be completely on the calculator. So the first thing we need to do is just simply graph the equation. All right, so I graphed it right here already. There's the equation. I typed it in this way. I put negative 16x squared plus 64x plus 32. This is what it looks like. Okay. Now the problem is I have no idea where the vertex is. I know it's somewhere right around 2. Maybe it is 2, but I'm not certain. Okay. And I tell you guys because sometimes these graphs are so large that you don't know when it's coming down. So the easiest way to find the vertex is by doing negative b over 2a. And I do consistently start this way. So I'm going to set the calculator aside real quick. Just do a little bit of handwork. Start off with negative b over 2a. And remember, that comes from the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you rid yourself of this discriminant portion right here, you're left with negative b over 2a. And what that is that's going to be the x value of your vertex. Okay? So negative b over 2a, negative 64, over 2 times a, which is negative 16, so 2 times negative 16 is negative 32. So the x value of the vertex is 2. 2 comma, and then the y value of the vertex. Now, keep in mind, what a vertex is it's either going to be the maximum or the minimum of a quadratic, okay? So the x value of the vertex, so that means it takes 2 seconds for it to reach its maximum height of, and we don't know what that maximum height is yet. We just know it takes 2 seconds. To get the maximum height, you take the 2 that you just solved for using negative b over 2a, and you plug it into this original equation. So 2 squared is 4. 4 times negative 16, that's negative 64. 2 times 64, so 64 times 2, that's going to be 128. So 128 minus 64, that's positive 64, plus 32, so that's 96. Now, the reason I start with that is because now on this graph, which it's going to be hard to see, I'm going to go ahead and zoom in. Keep in mind, here's your vertex, 296. I'm going to zoom in. Okay, so I'm going to change my window settings. And the way you do that, and the reason I want to is because I want to see the whole graph. You go to Menu, you go to Window Settings, all right? Now, the x minimum, we really don't care about negative times, so it doesn't need to be anything negative. So it really needs to just go from 0. However, I'm going to go ahead and do like negative 1 maybe, so I can see just slightly outside of the graph. Now, if it reaches its maximum point, so look here, right here again. So the maximum is at 2 seconds. So it should be about 4 seconds when it comes back down and hits the ground again. I'm going to go just outside of 4 seconds. I'm going to go maybe, let's say 5. Let's go 6. Why not? You can't make it too big. You just want to see the graph well. You want to see the graph well. Y minimum, let's go 0. And let's go up to it. It reaches a maximum height of 96 feet. We just found that out. So I'm just going to go up to 100. Now I should have a window that views this fairly decently. Okay? And that's what I'm looking for. I'm going to go ahead. I like to typically get this stuff out of the way. So I just click, hold, and drag it to the side like that. Okay. Now let's start answering some of these questions. So the first question is, where is the arrow at 2.5 seconds? Well, to answer that, let me zoom out a little bit. To answer that, it's really easy actually to use this trace option. You're trying to find when x is 2.5 seconds or when t is 2.5 seconds. That would look like a vertical line at 2.5. And I don't know how to do that on the calculator very well. I'm sure there are ways, but I usually just use this menu trace, which is 5, and then that graph trace, the top one. And then if you type in 2.5 seconds into this, it tells you it's at 92 feet. You can see that. Maybe if you wanted to find, for example, like 3.5, press enter. It tells you, oh, it's at 60 feet. All right. But again, we're looking for where is the arrow at 2.5 seconds. So 2.5 seconds, it's at 92 feet. So I would just write over to the right side of this question, 92 feet. All right, next one. When is the arrow at 32 feet? When is the arrow at 32 feet? Okay, so the way to do that is you just come over here. I mean, the easiest way. Again, I'm showing you guys how to do it on the calculator. Algebraically, you would take 32 and plug it in for the y. But the easiest way is if I create another equation that's 32. Now ask yourself, what is that doing? That's going to create a horizontal line, right? A line across this screen that's 32 high. So the question is, when is this function at 32? Right there and right there. Those are the two spots that it reaches 32. So I'm going to find exactly where the two spots are. So I'm going to go to Analyze Graph. 4 is intersection. And then I'm going to click here in the middle. I'm just going to highlight over here, and it says, oh, it reaches 32 at 0 seconds. That means it's shot, off the ground. And it reaches 32 at 4 seconds. Okay, so those are my two times. 0 and 4. 0 and 4 seconds. That's what answers right here. When is the arrow 32 feet? At 0 seconds and at 4 seconds. What is the maximum height of the arrow? Well, we actually already figured that out with the vertex. It took 2 seconds to get there, remember? So the maximum height is 96 feet. To just see, we can go ahead and let's make sure you press menu. Well, hold on. First, let me get rid of this 32 that I just typed in. Okay, so let me get rid of that. But to find out what the maximum height of the arrow is, you can press menu, you go to Analyze Graph, and then this vertex specifically is a maximum, not a minimum. So I'm going to press 3 for maximum, and then I'm going to highlight right here. And then sure enough, it says the vertex is at, in 2 seconds, it reaches 96 feet high. Okay, so that's the vertex, 2 seconds. 96 feet high. So what's the maximum height of the arrow? 96 feet. How long does it take to get to that height? 2 seconds. Okay. What does the vertex mean in this case? Again, it takes 2 seconds for the arrow to reach a maximum height of 96 feet. Next question. What is the y-intercept? Well, actually, we figured that out a second ago. The y-intercept, if you look back at the equation at the top of the page, here, I'll zoom out just for a second. If I look at this equation up here, the y-intercept is when I just plug in zeros for all the x's. So 0 here, 0 here. So all I'm going to be left with is 32. And sure enough, also when we found when is the arrow 32 feet high, we found that it was at 0 seconds. And we also found that it was at 4 seconds. So the y-intercept in this case is 32. Okay, so going on, what is the y-intercept? What does the y-intercept mean in this case? So it means that it's just launched from some platform that is 32 feet high. Okay, so let's keep going with that. Almost done. How long is the arrow in the air? Well, to find the answer to that question, you need to find your roots. So notice there's a root here. There's a root right here. And there's a root over here. And that's my objective. All right, so I'm going to go ahead. I'm actually just going to look at my cursor. It's right here in the middle of the graph. If you just click and hold, it gives this little fist like you're grabbing the graph. And I'm just going to move it up so I can see a little bit better. Okay, now I'm going to do menu, Analyze Graph, and I'm looking for, remember the x-intercepts, right, or the roots or the solutions, they're also called zeros. So I'm going to go to 0. I'm going to click here and I'm going to highlight. How long is the arrow in the air? Well, that's when it hits the ground right there, 4.45 seconds later. So 4.45 seconds is when this arrow that starts at 32 feet high, flies up in the air, reaches a max height after 2 seconds of 96 feet, comes back down, it hits the ground at 4.45 seconds. Okay. Next question, what are the roots of the graph? Well, there's 4.45, and the other root is, unfortunately I can't see because it says lower bound in the way, negative 0.449, or negative 0.45. Okay, so those are the roots of the graph. What do the roots represent? Well, actually this negative one is talking about negative time, so it actually represents something that's impossible. Okay, and then the other one simply represents the time that the arrow has a height of 0, because that's what the y value is here, 0. So it represents the time that the arrow has a height of 0, or also known as the time that the arrow hits the ground. Lastly, will the arrow ever reach 98 feet? No, we can show that by just, again, let's analyze a graph, look at the maximum. The maximum that vertex actually reaches the maximum height of 96 feet. So will the arrow ever reach 98 feet? No, the maximum height is only 96 feet. Okay guys, well I hope this was helpful. Probably most of you can already do it, but if not, then I'm pretty sure you guys had this calculator downloaded on your computers, so you should be able to get some good practice in. And I'm always here early in the morning, so come by for questions if you have them.